Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. Let x be a discrete random variable with moment-generating function m sub x of t equal to 1/4 times 1 plus e to the 10t plus 1/2 times the sum from n equal to 0 to plus infinity of t to the nth over n factorial for t between negative infinity and plus infinity. Find the probability that x is greater than or equal to 3. So obviously the problem is that we are given the moment-generating function, but we need to have some information about the probability distribution. And the important thing to remember is that when you have a random variable x that is discrete and assumes values x1, x2, x3, and so on, with probabilities p1, p2, p3, and so on, then its moment-generating function is m sub x of t equal to p1 times e to the t x1 plus p2 times e to the t x2 plus p3 times e to the t x3 and so on. And this is if and only if, basically, that this MGF, moment-generating function, gives you that distribution, and that distribution gives you that MGF because MGF, or probability distribution, is fully determined by its moment-generating function. In this case, m sub x of t is equal to 1/4 times 1 plus e to the 10t plus 1/2 times the series from n equal to 0 to plus infinity t to the nth times n factorial. Well, that's 1/4 times e to the 0 times t plus 1/4 times e to the 10t plus 1/2 times e to the t, because this last expression is simply the power series expansion of the exponential function. So that's 1/4 times e to the 0t plus 1/4 times e to 1 times t plus 1/4 times e to the 10t. I just rearrange the terms so that you have 0, 1, and 10 in increasing order as, obviously, the three values of this random variable x1 equals 0, x2 equals 1, x3 equals 10, with probabilities p1 equal to 1/4, p2 equal to 1/4, and p3 equal to 1/4. And the probability that x is greater than or equal to 3 is the probability that x is 10, because the other two possible values are 0 and 1. And notice that these probabilities, of course, add up to 1. So these are the only possible values of this random variable. So x is greater than or equal to 3 if and only if it is equal to 10, and that happens with probability 1/4. Therefore, that's our answer. Answer B. Please remember, this is copyrighted material. The problem was written by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.